Good morning, folks. Welcome to lesson 5 of resource management. Today we're looking at energy in the UK, and we're looking at something called the UK's energy mix. That is, we're looking at the proportion of energy that's made through the use of fossil fuels, renewables and non-renewables. We are also going to look at the reduced domestic supply of coal, gas and oil. In other words, they're running out. And we're going to look at some of the issues associated with energy production. So they might be advantages of using certain types of or certain methods to making energy, for example, wind power or solar power. And we'll look at disadvantages of those methods as well. Okay, before we continue, it's important that you understand the difference between three terms: renewable energy, fossil fuels, and non-renewable energy. Renewable energy is things such as wind, solar power, hydroelectric, tidal, geothermal. These are ways of generating energy which will never run out. That's why they're called renewable. They can keep on going forever and ever and ever. Fossil fuels are fuels that have been formed over millions of years by either dead sea animals or dead plants. So over time, dead plants have become compressed into rock and formed coal, for instance, or dead sea animals have been compressed and turned into a liquid, which would be oil. So that's what fossil fuels are. They've formed over millions of years. That makes them non-renewable because as soon as we have burnt them and they've gone, they are gone. Because it takes them such a long time to form, we cannot possibly call them renewable. And the third term is non-renewable. Non-renewable is not a fossil fuel, but it's something that will essentially, over time, run out. So, for instance, uranium that is used in nuclear power stations, that's known as non-renewable. It cannot continuously keep going and going and going. However, it's not a fossil fuel. It's not been made in the same way. Okay, on this slide, you've got three pie charts down the left-hand side, which are showing the UK's energy mix and how it's changed over time. The bullet points for the different types of energy production match up with the colours. I want you to pause this slide, think very carefully, see whether, it's a bit of a guessing game, but see whether you can actually think your way into making some really good educated guesses as to which colour goes with which energy source. When you think you've done that, move on to the next slide, see how close you were. Okay, so how close were you? So the green, which started off with almost about 70% in 1990, came from coal. So 70% of our energy came from coal, incredible amount. And as you can see, in 2007 it halved. 2014 grew slightly, but overall it's decreased. The purple, gas. Gas, not very much in 1990, but suddenly massively exploded into the UK. In 2007, it made up almost a third of our energy production, and it's decreased slightly by 2014. What other colours have we got? Red. So red is our nuclear power. That has always been fairly significant in the UK through those three different pie charts. The light blue, renewables. In 1990, hardly any of our energy came from renewables. Maybe that's about 3%. Same in 2007, hardly any. But then all of a sudden in 2014, it suddenly started to grow. In fact, that's probably grown by about 5-fold. So there you see, we are changing in terms of our energy mix. Now, I've actually added onto this slide two other pie charts, one from 2017 and one from 2018. I'd like you to pause this and just study them carefully, and then I'll talk them through. Okay, I'm going to talk them through. The thing I want you to notice is the coal. So as we know, over time, coal has decreased in the UK, but in 2014, it was still fairly significant. It still made up 30%, by the looks of it, of the UK's energy production. However, when we look at 2017, it's the very dark blue colour. It only makes up 9.1%. It's deteriorated massively. And when you look at 2018, it's declined further to 5.7. When you actually look at 2019, which you can't see here because I've not included it on the slide, it's decreased right down to 2%. And they're actually hoping that by the year 2025, we will have no energy production from coal. So it has decreased massively. Other interesting things to pick out on these two pie charts is the renewables. So the renewables in 1990, we said were about 3%, and they weren't that different in 2007. In 2014, you can see that that blue segment has grown a lot. But now look at it in 2017. The renewables are the very light colour there on the pie chart, the very light colour that makes up 30.1%, it says. So just within 3 years, it's doubled from 2014. And then if you look again at the next year, 2018, it's grown even more to 37.1%. The expectation is that by the year 2025, most of our energy will come from renewable sources. So we can see how much it's changed there. Nuclear, well, look at the nuclear segment. We've got 18.1% in 2017. We've got 16.5% in 2018. It's staying pretty similar. It's been pretty significant throughout in terms of the UK, hasn't it? And the pie charts on the left, it's in red. And you can see it's always been fairly significant in the UK, and it looks like it's going to continue to be fairly significant. Gas is interesting because gas actually currently accounts for the most energy in our country, which is still a fossil fuel. But in the future, that may change. Question 1 there is, how has the UK's energy mix changed over time? I'd like you to answer this question in your books. Pause this slide. I want you to use the pie charts. You should identify major trends. So I would definitely talk about what's happened with coal. I would talk about what's happened to gas. You might want to mention that nuclear is staying pretty much the same. And I want you to talk about what's happened to the renewable sources. So state whether they've increased and decreased. Try and use numbers in your answers to give yourself a much better answer. Try and manipulate the data as well. So you might say things like it's doubled or it's tripled. That's called manipulating the data. So use the pie charts, write your answer. My answer is on the next slide. Pause this slide, and when you've done yours, you can have a look at mine, compare them, and then maybe do a little bit of dirt work on yours to improve it. Okay, there's my answer. I just want to spend a moment or two talking through my answer so that you can understand the skill involved in writing these. So I've not talked about all the pie charts, but I've picked out a few. In 1990, the UK relied heavily on fossil fuels and non-renewables, like coal, oil, and nuclear. Have a look at the pie chart, see if I'm right. So that's the green, oil is the yellow, nuclear is the red, and I'm saying we're relying on that, and we were. This made up about 90% of energy. If you add up those three categories, that's probably about 90% of that pie chart. Now they're all non-renewables and fossil fuels. Renewables were low. So I'm just describing, I'm not explaining, I'm just describing. By 2007, the use of coal had halved. That's manipulating the data. I've not just said it's about 30%, I've actually said it's halved. Gas increased massively to almost 30%. Fossil fuels and non-renewables still generated almost 90% of energy if you add them up. Renewables stayed low. That's the blue. So I'm trying to keep it simple, I'm just describing. By 2014, there was a small decrease overall from renewables and an increase in non-renewables, and an increase in renewables from about 3 to 15%. That's the blue segment. Now I'm going to jump straight to 2018. By 2018, big changes have happened. Coal has plummeted to just 5%. Gas is still used fairly heavily, but fossil fuels are in decline. Renewable energy has rocketed to about 40%. Okay, so that's describing the pie charts, trying to put things into categories, using numbers and manipulating the data. And that would be like a level 9 answer. So when you go back to your answer now, did you keep it vague? Was it basic? Did you use numbers? Because if not, rewrite or add to it, make it sound good, make sure what you're writing is correct. I'd pause this slide, reread through mine again and get your head around it, then move on. Okay, now we want to look at reasons for these changes. So before you move on to the next slide, which talks through my answers, I'd like you to think about why these changes have happened. So in doing that, think about why might the use of fossil fuels have declined? Why might the use of renewables increased? Why might nuclear have stayed fairly consistent? In your head, see if you can think up some answers to that. You might even want to ask your parents, see if they can come up with any ideas, and then move on to the next slide. Right, reasons for the changes. Well, concerns about greenhouse gases, carbon dioxide emissions. That's led to a decline in the use of coal. Coal is a fossil fuel. We have to burn it, and when we burn it, we release all of the carbon that has been stored in it. Because remember, fossil fuels are dead plants and animals that have been compressed, and all plants and animals contain carbon. If we burn that, we add that carbon to the atmosphere, and it leads to global warming, which is one of the biggest threats to mankind currently today. Therefore, there is an awful lot of pressure on governments to stop using fossil fuels. So that's one reason why there is a decline in the use of coal, because it's bad for the environment. Secondly, the UK has exhausted 75% of its oil and gas reserves. So we had plenty, but we've used 75% up. We've not got much more left. And the bit that's left is really hard to get to. So it might be in really, really remote places where there's no roads to get to it. It might be in the sea, for instance. It might be in mountainous areas. It's in places that are really hard to get to it, which makes it very expensive to try and get it. And therefore, people are a little bit less wanting to get it because of the costs associated with it. Okay, thirdly, renewables, so wind power, solar power, etc., they are environmentally friendly. They don't run out, that's why they are renewable, and they don't produce any harmful greenhouse gases. So they're very good for us. They're good for our health, unlike coal, which leads to horrible breathing conditions. Finally, by 2020, if we carry on as we are, we would be reliant on importing from elsewhere. That means that we're dependent on other countries, and that's not a good thing. We need to have our own energy sources, which would make us energy secure. And that's one of the reasons why we are spending money now building wind farms and solar powered farms, because we're trying to invest our money in making our own energy. If we import energy from other countries, we have to pay what they are asking for it, and that makes us very dependent on them because it's something that we need, so it can become very expensive for us. So we are now investing a lot of money in our own renewables. This answers some of the changes. I would like you to have a go at answering that question that was on the previous slide, please. You may use the answers here on this slide as well to do your own work. That's a nice image. That's an image showing the London pea super days when we burnt loads and loads of coal. So this is back in the 1960s. We burnt loads and loads of coal, and we didn't have any kind of environmental regulation on the pollution that was put into the atmosphere. And London suffered with many days where you could barely see more than a few meters because the smog from the pollution was so bad. That's one of the downsides of using coal. That's when we burnt a lot of coal. Okay, will fossil fuels disappear completely from the UK's energy production? What do you think? Pause this slide, have a think about that for a moment. Do you think we will ever stop using fossil fuels in our country? Okay, it's unlikely. We will still use fossil fuels, and here are the reasons why. We actually still have reserves of them. We've discovered recently something called shale gas, and we've got a fair amount of it in the UK. which could keep us going for several decades, so 10, 20, 30 years. So it's unlikely that we're not going to touch that. Of course we are. Secondly, coal is cheap. The importing coal from elsewhere is fairly cheap because it's so dirty and quite polluting and not brilliant for people's health. It's a cheap energy source. So we probably will keep buying it simply because of the cost. I've just said about the shale gas. It's unlikely that we'll ignore it. It's a potential resource for us, and that's what fracking is. You may have heard of the word fracking before. Fracking is the process of getting the shale gas, which includes blasting liquid down in like a jet, a bit like a jet washer, down into the Earth's crust to break the rocks and release the gas. And oil is what we currently put in our cars. Most of us use petrol, and that is oil. And when you think about the millions of cars we have on our roads that are petrol or diesel, we are still using and we still need oil. And the chances are we're going to still need that in the future. Yes, we're moving towards electric vehicles. There are some changes happening in the UK, but currently these changes are happening fairly slowly. We are behind other countries when it comes to investing in our infrastructure to allow us to have electric cars. I mean, you could say, oh, we could all have electric cars in 5 years' time. Well, we can't if we don't have the recharging points. We'd need these in our own homes, wouldn't we? Currently, it doesn't exist, so it's going to take some time. So in the near future, fossil fuels will still be a part of the way that the UK gets its energy. I suggest you make some notes from that slide and then move on. Okay, what about demand? What about demand and what we want, and what about what we actually consume? I would like you in your book do a quick sketch like that of that graph, and you draw. So you're having a guess here. How has demand changed over time? Demand is what we want. Has it gone up? Has it gone down? Has it stayed the same? You draw a line. Secondly, how has consumption changed? Consumption is what we actually use in terms of energy. Are we using more? Are we using less? Is it staying the same? You draw your lines and then flick to the next slide to have a look at what's happened. Okay, that's actually what's happened over time. Demand has risen over time, and that's because our population is increasing and we are buying more and more gadgets and pieces of technology that require energy to make them work. So yes, demand has increased over time. We cannot argue against that. Consumption is interesting though, because my blue line showing consumption shows that it's gone up with demand, but it's actually also started to go down. Can you think of a reason for that? Here is the reason. We are more energy efficient now than ever before. So yes, demand increased, we want more energy than ever before, but consumption, our usage, has actually decreased because we're more energy efficient than we ever have been before. For instance, yes, we're all powering our homes and lighting them. We put lights on, don't we, all over the house, but our lights have got better. They don't use so much energy. Our washing machines, the technology has improved over time. They don't use as much energy. So because of that, we're actually consuming less. So we're demanding more, but we're consuming less. Those are some examples of how, like I've said, we now use energy-saving light bulbs. We use low-energy appliances. We insulate our homes better as well, which means that we don't lose as much warmth from them. So therefore, we don't need to have the heating on so much. Even our cars have become more fuel efficient. I remember when I was learning to drive, my car would get about 25 miles to a gallon of petrol. Now it can get something like 50 miles to a gallon of petrol. So it's changed a lot. Our industries are using about 60% less, and in the home we're using 12% less. So although our demand has increased and we want more energy than ever before, we're actually using less. Make a couple of notes on that, please. Just a summary point in your book that states that demand has increased, but consumption has reduced, and why. And then move on to the next slide. Okay, so let's have a look at Britain's future energy mix then. We've said that we're investing in renewables. That's a great thing. Here are some examples of renewables. So that's wind farms on land and in the sea. That is a picture of a solar farm. You can see that picture of the panda down in the bottom left. That's all made of solar panels. That's actually in China. It's not in the UK, but I thought you'd like the picture. That's a picture of a dam with a reservoir behind it. And as you can see, water is coming through the dam, and that will be turning turbines, making electricity. We call that hydroelectric power. That's a picture showing tidal power. Works in the same way. The tide and currents come through the turbines and spin them round. So it can generate energy when the sea comes in, when the tide comes in, and when it goes out. This is called biofuel. It's considered to be carbon neutral. In other words, plants are chopped up like that into wood chippings and burnt. And you could say, well, doesn't that release carbon dioxide? Well, it does, but when they're alive, they take carbon dioxide in. So it's like a balancing act. That's why they're known as carbon neutral. So yes, they've taken the carbon out of the atmosphere, then they've been burnt and they've put the carbon back. So it's like zero. That's a geothermal power plant. That's using the heat from deep under the Earth's crust. Particularly good if you live in areas where there's volcanic activity and the magma is quite close to the surface. So the bottom right picture there is showing that they pump cold water down under the earth, into the earth, and then it gets heated up by all the hot rocks, and then it comes back up to the surface nice and hot, and the steam turns a turbine which generates energy. And then we've got the non-renewables. A couple of pictures of non-renewables, just so as you know, that's an oil rig out to sea, and that's an oil rig on land. And the top right picture is, pollution coming out of a chimney stack from the burning of that oil. It's a picture of a coal mine. You probably would recognise that. Horrible, ugly scar on the landscape. This is a gas power station. And so we need to look now at the future for Britain. What I'd like you to do is make a table in your book, a little bit like the one you can see on this slide here. You need to have 3 columns. So in the left column, you're going to write down the energy source. Then you need a column for economic challenges and a column for environmental challenges. We're going to focus on wind power. Obvious reason really that the UK is, or Britain is an island, the British Isles. We're surrounded by ocean and we get a lot of wind. So therefore, we're going to be focusing this session on wind power. I would like you to brainstorm all the possible economic disadvantages of wind power. So economics to do with money. I'd then like you to think about, could there be any environmental disadvantages of using wind power? Have a go at that and then flick through to the next slide to see my answers. Okay, add to your table this time, but for fossil fuels. Now, we know that we're not using coal in the future and we're running out of oil. So shale gas is what we're going to be probably using. The picture there of the UK, the orange areas, no, sorry, the red areas are areas where we are already fracking for shale gas. The orange areas are the available areas that we might frack for gas in the future. Now that covers quite a big portion of the UK, doesn't it? So I imagine we're probably going to get a lot of energy from fracking for shale gas. You can see what people think about it down in the bottom right. Those people live in or near those areas that are red, that are already licensed, and they're unhappy with fracking. But again, I'd like you to complete your table, add on the disadvantages economically and environmentally for shale gas, and then move to the next slide, please. Okay, and finally, nuclear. We said that we've always had nuclear in our country. Chances are we will moving forward. So I would like you to brainstorm the possible disadvantages of using nuclear as well. Again, as many as you can think of, and then move to the next slide. Okay, and here are all the possible answers. Now, if you don't want to hear me drone on, I suggest you pause this slide and just have a read through all those different challenges from these different types of ways of making energy. I would like you to add to your table, please, because I imagine you've got some things down that are correct. You might have some things down that aren't correct. You can always forward me your work and I'll give you some feedback. But I'd like you to add in my ideas too into your table. Now, if that means you need to draw up a new table because you haven't got space, then go ahead and do that. Or you could just, put a little code on your table and just add to it. Now that was the challenges. What about the opportunities though? What about the advantages of these different sources? Well, here are some advantages for us using renewables. Economically, loads of jobs are created. We've got to design the solar panels, the turbines, we've got to make them, we've got to install them and look after them. All of that will create job opportunities which will lead to a multiplier effect. Environmentally, there's absolutely no carbon emissions given off by renewable energy. It's very, very environmentally friendly. There will be some carbon emissions in making the turbines, but once they've been made and installed, they will generate electricity for many years without producing any gases. That's a huge opportunity. Fossil fuels. Well, there are advantages. Economically, again, it creates jobs leading to a multiplier effect. Environmentally, there aren't really advantages from using fossil fuels. However, I have written there in that column that carbon capture and storage, which we've learnt about before, could be used to actually capture the carbon on the way out of the chimney stack, which would reduce the amount of harmful gases going into the atmosphere. Nuclear. The advantages of using nuclear power, again, creates loads of jobs and a multiplier effect. And actually, nuclear power, although it's very, very expensive to build a nuclear power station, like £18 billion, after it's been built, the energy can generate tons and tons of energy, loads of energy, for a very cheap price. So that's a huge economic advantages in the long run. Environmentally, it's cleaner and less polluting than fossil fuels. Not as good as renewables, but it's much better than fossil fuels. I'd like to have a go at these two questions, please, based on what you've learnt today. And then we're pretty much at the end of our lesson. So, a recap, please. Just to check, you understand that the UK has an energy mix. That means it's made up of different ways of producing energy and that it's changing over time. You should have learnt that we've had a reliance on fossil fuels over the years, but they are in decline and we are now growing in the amount of renewables that we use. You should have learnt that coal, gas and oil are running out, except for shale gas, which is something that we've recently discovered. And you should have learnt about the economic and environmental issues. That's mostly the challenges, the disadvantages associated with using the different energy sources. And we had a little look at some of the advantages too. Those were the three things you needed to learn about today. You should have an understanding of those three things, and if you do, then you are on track and well done.